So, in terms of the result that I got the other day by applying the uncertainty principle to black hole singularities and trying to think about the angular momentum in real terms of a photon at the very center of a black hole would be a gamma ray photon, which is what I suspect is the form of matter or mass energy, if you like, present at the center of black holes. Sorry, I'm looking up and to the left all the time. I've got it written on a board up there, and I keep looking at it. I should know it in my head, really, should I not? So yeah, I've been toying around with this idea and toying around with this equation. I guess what that would be is the perturbative solution to it. So I selected an arbitrary coordinate system, and I've decided to call the point at the event horizon of a black hole 1, and then I'm calling the, well, not the singularity as such of the black hole 0. Well, I am sort of saying it is 0, but what I'm really sort of saying about the position or the ultimate or the extremum in terms of position of the photon is saying it's basically 0. So it's zero point 0.1 times 10 to the minus infinity, which isn't 0, but it's as close to 0 as you can get in a black hole, if you know what I mean. Or like it never really achieves 0, it's an infinitesimal, which is sort of a bit of a baroque idea now, I think, and it's sort of an idea that you don't really come across in physics all that much now. However, it is, I think, it's a very fundamental idea in calculus. So I wanted to use it anyway, just to sort of see whether or not that could be used as a means of absorbing infinities, and I think it probably can be used in that way. So the equation of angular momentum and the uncertainty principle would be so you got momentum, no, sorry, position, like the x coordinates, or r if you like, if you want the classical equation of angular momentum. So it'd be so x1 minus x2, i.e. where it started from, the position it started from, the position it's ended up. So x1 is 1 in the arbitrary coordinate system that I've selected. x2 is 0.1 times 10 to the minus infinity. Then multiply that by the speed at which it started, which is c, light speed, or 300 million meters per second. Then minusing that by the speed it ends up at, which likewise I think is also infinitesimal, because I think that the linear momentum through space or through the incredibly dense regions at nearly the center of a black hole slows the linear momentum as opposed to the angular momentum of the particle to basically nothing or so. So that is 0.1 times 10 to the minus infinity. So really what you end up getting out of that is, of course, what you really should expect from I'm going to say also the angular momentum of a photon from a given reference frame, which is really kind of crucial. From the reference frame of the black hole's exterior, the whole black hole is spinning at light speed, so you'd expect the very center of a black hole to be spinning at light speed also, which from the reference frame outside a black hole, crucially, is the truth, I think. Or it is the truth. It is the truth indeed. It's like the centre of the Earth spins at the same speed the Earth does, right? Likewise with the centre of any rotating body. However, from the perspective of the interior of the black hole, or the regions very near the singularity, the photon is spinning at a different speed. So it's not. So you can then adjust your equations to make them non-perturbative. And or really, like what's closer to the truth actually is it's not spinning at a different speed. It's spinning at two speeds at the same time. So its angular momentum is a sort of bivector, if you like. It has two vectors, vector quantities associated with it, or might you call it a tensor or tensorial or something of that nature. So yeah, I think I calculated that the angular momentum of that particle in a non-perturbative sense is something like 2.24 something times 10 to the minus 27 meters per second, which is some very, very slow number of meters per second, or it's a really, really slow rotation. Um, but it is also, in the strict sense, because it's rotating within the whole thing, also moving at light speed, just to confuse you. And 2.249, whatever it was, times 10 to the minus 27, that's a nice number to have, because that is greater than h bar over 2. So that's a nice reason for having that there.